debaters and debunkers. Wanted to do a little bit of eye-level science, having recently posted a video trying to explain eye level and eye level horizons and how to measure them, and I still got comments from anti-flat earthers, I suppose, and I will address Wolfie 6020 directly in this one, just to clarify for everyone's understanding what eye level is. So we'll wait for a couple of people to join, as this is a live one. I'm doing this from the garden on a Sunday morning, a Sunday afternoon here in Phuket. Hello, Zeus Scott. Top of the morning to you. Afternoon here for me, but I expect, yeah, you're just getting up for the morning there. Hope you're having a pleasant Sunday. Who have we got there? Rodrigo, hello. All right, and Milky. All right, Mark. All right, coming in. Good to see you all. Yeah, so I'll just give you a quick view of the surroundings. This is I'm in the garden under this rose apple tree. I found it. I was going to do it there, but it was too noisy. So, this is the garden. It's growing wildly at the moment because it's the rainy season. So it's difficult to do gardening, and it all just kind of very quickly grows. So, and this is me. Hello. And yeah, I've put a few diagrams together. Of course, we all know what we're talking about when it comes to eye level horizons, and shout out to Eric Dubé. Really, he was this is we're talking about 7-8 years ago now. It's probably the same for a lot of us, right? Where we started seeing these videos about flat Earth, and the one thing that struck my mind straight away was Eric Dubé reminding us all that the horizon is always at eye level. And I was thinking, well, yes, of course it is. And you see, it's funny because if you're taught about perspective and things like that, then we all know what eye level is. It is the horizon. And in real, hello there, John Tor, hello. We're always taught that the horizon is our eye level. That's what we see. Oh, hello, Ross. So we're going to go through a couple of things today, and we're just going to talk about the distance to the horizon as well, and how that has been, what's the word? Twisted. Yeah. Oh, I'm on Globebus, am I? Okay. All right. Okay. Okay. Now, the last video I did. Oh, okay. Well, oil, beef. Okay, tooth. Okay, never mind. You go off to. You have to go to bed. You get yourself off to bed and catch up in the morning. Huh? I'm doing a video now. Doing a live stream. Yeah. Okay. Okay. Right. Last video I did, it was very clear. We all talked about eye level, but we were lacking these kind of side-on diagrams. Okay. So let's just clarify what eye level is. And of course, the horizon dropping from eye level is supposed to be something that would happen if you're living on a sphere or anything, any shaped Earth really. If you were depending on the shape of the Earth or the dimensions of the Earth to cause or create your horizons, then yes, that you're then talking about observing something with a fixed dimensions, and which is going to drop off when you rise up. But really, this is the thing that horizons don't really prove anything apart from as long as when you understand how our vision works. And of course, we understand that we are indeed looking across a level surface, and we always know that. We've always known that, and all we get is excuses. And this is the main thing, the main problem with the Globe Earth Defenders, and quite frankly, it is their dishonesty, their disingenuousness, and their inability to agree on first principles and agree to the things that we all know by consensus as being things like eye level. Yeah, they know exactly what you mean when you talk about an eye level horizon. It's always there. I mean, even to get someone to, even if you ask someone, where is the horizon in your field of view? If you're just standing on the surface, where is your horizon in your field of view? They will avoid saying where it appears for all of us. Okay, and there seems to be, now this is either stupidity, it's either stubbornness, or ignorance, or deception. Because one thing that seems to be difficult, I think, or at least they'll pretend or feign difficulty understanding or getting even, is this fact that we've got, when we have a picture of a horizon or a landscape, we've actually got two observers, but really when we're talking about an eye level horizon, we're talking about the observer. This is the eye of the observer, yeah? But often what we have, especially if we're looking at these views, is the eye is replaced by a camera. Now, you could have the eye looking at the camera, but really what the camera is doing is acting as an eye. It has a convex lens, the same, and it has this perspective, the same as we see the world. The lens of a camera is very similar to the lens of an eye, isn't it? It has to be so that the images that it produces make sense to us. Yeah. So this is one thing to first of all understand, that the observer that we're usually talking about is us, our eye level. Okay, but of course the observer, if we're taking a photograph, then the observer becomes the camera, and it doesn't matter where you hold that camera, then we're talking about the camera's eye level. So a very simple illustration here, which I hope kind of gets the point across for both meanings of eye level. Okay, this is what we're talking about here is eye level. All right, and there's two meanings really. Yeah, nicely said, Ross. Iris level, absolutely, yeah. So it's very easy, okay? We have the surface here, a level surface, okay? We have our height, the observer's height, and that's 2 meters off the ground. And this is the exact center of the eye, okay? And the same with a camera. If we're going to have a camera that's targeting something, it's going to be 2 meters off the ground. And when we say 2 meters off the ground, we mean the exact center of the lens, all right? Not the base, not the top, all right? The exact center of the lens. And here is our target with a bullseye in the middle. So we are aiming for this bullseye, yeah? And that bullseye, not the bottom or the stand or anything, is also 2 meters high. So what we have here is that one definition of eye level where we are talking about the height, okay? The height of the observer is also referred to there as their eye level. And for example, you could, if you're looking at this camera, you could look up or down like this, and you are still maintaining the same eye level, but your line of sight is not in line with your eye level, okay? And eventually, at some point over here, you're going to get your horizon where everything converges, yeah? Now, of course, the height of the target is a physical height. The height of the camera, the height of us, is a physical height. The horizon's apparent height, okay? We know that the surface isn't bulging up. So here's what we see in our field of view when all of these things are lined up. Now, this could be our field of view as seen through our eyes down here. That's what I've got here on the back here. So projected onto this is our field of view, comes down here and we see it down here. Okay, the field of view. This is what we will see. We know that the stand here, or the target, the height of the target is 2 meters. Now, it doesn't matter what height that is. We will see the target in the center of our field of view. Now, whether the camera, the eye or the camera is the field of view, the eye level is the center of the field of view when we're looking straight ahead, okay? This line here is level, so that's why we call this an eye level line of sight. If it's going down there like that, it's not eye level. This is an eye level line of sight. So it's, again, just as we have here, okay? Yeah, we're dealing with right angles, yeah? There is no denying on any of these globe or flat earther sides, if you like, what level means. Okay, it's there's your vertical down, there's your right angle, there's your horizontal. So along this line is level, physically level. Okay. That is the physical definition of level. If you have 1 point here or 1 point there, they are level. Okay, this shouldn't have to be explained. It shouldn't have to be demonstrated, but unfortunately it does, because there are so many people that like to pretend they're smart, but then suddenly pretend to be idiotic when it comes to understanding what eye level actually means. Yeah, and they'll jump to a different definition, which we'll have a look at. But this is the one thing again that really, any of you watching will understand that what we have here is this denial of the existence of other interpretations or other meanings in either layman's terms or common language. They just want to stick to the language that's used for their model, yeah, whenever convenient. All right, so yeah, this is the view that we get. Now, regardless of what shape you consider the Earth to be, your horizon, the surface, will appear to rise up to the eye level, the same apparent height as the center of our field of view. We know it's not a bulge. We know this is just what level surfaces look like when we look across them. Okay, so this is the forward-facing view, and that's what it will look like. Doesn't matter. This could be 20 meters. It could be 200 meters high. The view will be the same. Okay, that's how our vision works, regardless of the shape of the Earth. Unfortunately, they've come to define level as something else. Okay, now what we have with these in my last video, and I'm sure you've seen them before, is the photographs of a heads-up display. Yeah, and this claim that isn't erroneous, but it is misleading, and I'm sure deliberately so. You have a heads-up display, so I'm just going to kind of attempt to draw one. So imagine now we have the pilot, they have their eye level, or they're taking a photograph, and in front of them, we've got a pilot in a cockpit now, is their heads-up display. Now I'm going to exaggerate this a little bit. Okay. And let's put some funny lines in here for our, the kind of thing we might see in a heads-up display. We've got some angles that go around here. We've got some okay. And then we might have our little pitch indicator. I won't put that in to confuse. Now, the photographs will have been shown, so we can see that, we're just envisaging a heads-up. Okay, let's just label it. So it's, all right, heads-up display. All right. Okay. Heads-up display. Now the photographs we've seen, and then we can also add it. We can add it to this view as well. Okay. So just to be clear, that's what we'll be seeing. We would see this heads-up display, blah blah blah, like that in our view. So this is now being put. This is being put in between. Now, really, it's a straw man. It has nothing to do with what we are seeing. We are really talking about the relationship between the eye level and the horizon over here, where it appears to be, and it will appear to be at our eye level. Now, the argument comes a lot. The argument that's been inserted by these globe Earth believers in order to have their horizon appear above level or eye level is we'll have this image, we'll have a photograph of a heads-up display looking out across the horizon, but then we have this horizontal line on the heads-up display, which is above the horizon that the pilot is seeing. Okay, all right, and all you have to do, as I've shown in these previous videos, is look up at you look at the field of view, you look at the image taken by the camera, you find the center, you find where it is, easily done with these programs these days. If they're looking straight ahead, then, here is the center of our field of view, here is our eye level. But if you then put a HUD in between, and the line on the heads-up display happens to be up here, higher than our own eye level, the observer's eye level or the camera's eye level, then of course that horizon line on the HUD will appear above our external horizon. It's just a parlor trick. Okay, but then you have all of a sudden you're saying, no, even it's not even said. Again, Wolfie, you haven't used the word eye level to refer to this line. You call it true horizontal or something like that. But it's just like George Bush saying weapons of mass destruction, nuclear weapons, weapons of mass destruction over and over again, nuclear weapons, until the association is made. Well, of course, I think a lot of the time the globers understand exactly what we're talking about here, but they've got something to latch onto. No, we'll now call this level, we'll call this line that's above the observer's eye level as our level. We suddenly jump to using this as our level reference. You just brought in that, this is a straw man. Okay, it wasn't there to start with. Okay, and then suddenly you plonk it in there and say, oh no, well that's eye level now. Yeah. So it's, again, as I said, it's either stupid, deceptive, or ignorance when you continue to do that. And Wolfie came along to my video the other day and said, oh, you still don't know how HUDs work. We're not talking about how HUDs work, and that's the only excuse you have. We're talking about how our eyes work, how the lens of a camera works, how the field of view looks to an observer. Yeah, and the meaning of eye level that you all know very well when we're talking about the horizon appearing at eye level. That's what we're talking about. And the claim is that actually what we should do is as we gain height, we should see a horizon drop from our eye level, not from some arbitrary level indicator on some screen that could be anywhere. And this is the thing, when the globe Earth proponents talk about eye level, what they then do is they refer to eye level as height only. They ignore, again, this horizontal line of sight, even though they'll admit that it's perpendicular, okay, to your vertical. That's your level. But they'll say, but it doesn't matter which way you tilt the camera. And you know very well that if you tilt a camera, as I'm going to do now, then of course it changes the height of this camera doesn't change. But of course it changes where everything appears. Yeah? Okay. And of course we're talking about eye level views. Okay. So this is an observation. It should be very, very clear by now. Yeah. And let's just have a look at this in this kind of respect, okay, just to clarify what I see as going on when we have a view. Now, here again, what we've got is the surface down here, okay. We've got this 2 meters above the surface is where our eye level is, okay, and our horizontal view, our line of sight, our horizontal line of sight, okay. Now, what we do see, which is fairly accurate according to the mathematics, okay, is the distance to the horizon. As long as we are looking across a surface, then it's fairly accurate, yeah, that when, for example, you're 2 meters above the surface, the distance to the horizon for 2 meters is about 5.1 kilometers, which is about, that's 3.2 miles. Okay. Oops, sorry. And that's also 2.8 nautical miles. Yeah. Okay. 5.1, 3.2, 2.8, whatever. So we're talking, because we're talking about meters, we'll carry on using the metric system and talk about kilometers. Okay. So the distance to the horizon is fairly accurate. Okay. It is, of course, based on this assumption that the Earth is a certain radius, and the surface is completely, smooth, what have you. And so it works out, okay? But that's just the distance that we see to our horizon across a surface, okay? That surface is level. Our line of sight, our eye level, is parallel. And it's just that phenomenon that occurs in our eyes because of their convex lens nature that parallel lines appear to converge. We know that train tracks appear to converge, but of course this you just have to flip that around. We look at the train tracks going off like that, but if you just flip it around, that's also happening in our vision from top to bottom. Okay, train tracks, all right, the parallel lines of train tracks will appear to converge like that. Yeah, so when you're thinking about this, it doesn't matter, you all the way around this is happening. And this is what angular size is. You've got this decreasing angle, okay, to the center of the field of view. That's what this whole difference in angular size is. Yeah, all right, it's like a circle, yeah, in your vision, like a tunnel. Okay, so that it doesn't matter wherever these parallel lines are going, they will appear to converge in the center of your field of view. And obviously, if you tilt up, but it's something to do with your eye level as well. But anyway, that should make sense now. Okay, that should be really, 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 really clear. Yeah. So what we have here is this apparent rising of the surface, and that is where we see the horizon on the surface. Now, it won't always necessarily be, spot on at eye level, because you have a lot of distortion. There's all sorts of other stuff going on. And what I found in looking at this is you do have a gap. You do have a slight gap. It's consistent because it's that gap where you see the convergence. It's basically where the surface appears to stop. We stop seeing the surface, and we can't see really what's happening on the surface beyond that. The surface remains just here. The surface remains level. Okay, that surface remains the same. But this point here, this distance here, if our eye level is 2 meters across above the surface, 5.1, let's just say 5 kilometers in the distance, is about where we'll see the surface, the end of the surface. And this is when we get that hard line on the horizon. Okay, and it stops. But everything on the horizon, we could have someone on a bicycle, if you like, all right, whatever, yeah, and you won't see them, or you might see a lot cut off, okay, because it's just, that's the limit of where we can see the surface, but everything stays on the surface. Okay, and that's exactly what happens to the sun. It gets far away. Anyway, I'm losing myself now. So, we have this apparent rising. This is what gives us this view. Yeah, this apparent rising from here to here, from the bottom of our field of view, is illustrated like this, side on. Okay. Now, that's because we have a surface in the way, but the sky view, okay, up here, goes a lot further, thousands of kilometers further. Okay, we could even say that this might be something like, I don't know, we could say 6,000. I'm just making this up. Doesn't matter. Okay, we could say the distance from here to here is 6,000 kilometers or whatever. Okay. But just from here to the surface, that's as far as we can see across the surface. We're going to see a lot further across the sky. And of course, this is just an arc, isn't it? So we've got these angles of elevation. Again, if for example, let's do it. Okay, let's just show, we're getting into the whole navigational aspect of it now, aren't we? Here's a star with a ground point, what's called a ground point, yeah? Here is that star's ground point, okay? It's at a certain location, at a certain time. This could be the sun. We could even make this the sun, all right? That's easy enough to do, okay? So remember that all of this has been calculated and worked out hundreds of years ago, but basically knowing which point of the Earth or the sea, according to our coordinate system, is where this ground point, where is the sun? Above this point. And of course, from our eye level here, it's going to be a certain angle, and it's going to be a certain angle above our eye level. Okay, not necessarily above the surface. It doesn't matter, because the surface to us appears up here. Okay, so it's just going to be from our eye level. All right, and then we're going to have an angle that's basically 90 degrees. Okay, here's our 90 degrees coming into it again. Okay, all right, you've got our vertical here. All right, and then you're going to have a certain amount of degrees. Yeah. All right, so nowhere in this is the assumption that the light is coming to us in parallel lines. Nowhere. It's here. You see, in this part of it, it's very much understood that this ground point depending on the angle that we can see it above the horizon, it's all been worked out again. We will have two angles. We'll have this angle here, and we'll have another angle here. So we get an angle, we get a reading above the horizon, and then we take that from, let's call that x, and we do 90 minus x, okay, gives us what's left here, all right, whatever that degree is. So let's just say that's 10 degrees. So 90, so that leaves us with 80 degrees, okay? 80 is the kind of reading that we end up coming up with, yeah? And then we refer to this parallel line, okay? And then we've got two parallel lines to work with, okay? And the angles between parallel lines, okay? Whoop, there's one angle here. If I draw that somewhere down here, it's going to be the same. That angle is always going to be the same, isn't it? Okay? And away you go. So what you've actually got is this reference to light coming in parallel lines is basically you've got your star with a ground point that is known to be several thousand kilometers away from you in your particular location, or it doesn't matter where, if you don't know, it doesn't matter if you don't know where you are. That's the whole point. You know the angle, the angle of where you are, okay, to this particular star. You know that star's ground point, boom, is over there, so that you then know your distance. And it's just, and then we're turning it into degrees. 1 nautical mile, 60 nautical miles is 1 degree, isn't it? Yeah. 60 nautical miles equals 1 degree. Okay. So now all you've done is once you've known, okay, that ground point is over there and it's this many degrees. So it must be whatever, how many kilometers away from us. That's it. You know the distance, and the distance is expressed in terms of degrees. Yeah. That's all, and it's only because you've assumed a center point of a circle with a fixed radius, okay, that you then come up with this number. It's just general mathematics, yeah, because you've already got a fixed number to start with. Okay, hang on a minute. Where's my? Alrighty. So, hang on. I've just got to pull this paper up from here. I'll have a look at your comments in a second. Yeah, I'll just get through this. So, all right. So we've clearly established what level is. We've clearly established where these people are messing up. They're suddenly bringing in something that's not at eye level and referring to that and saying, oh, that's level. And look, the horizon we see in our field of view is below the level that we are now inserting into this field of view. Absolute nonsense, total straw man. Okay, but what I wanted, and again, it's understood that in this case, eye level is your height. Okay, fine. You can talk about eye level as being your height above the surface. And yeah, these are all at the same eye level. The horizon is at an apparent eye level. It's not physically there. Again, this is simply because of this whole thing where the surface does appear to rise up, and of course the sky appears to come down as well. So of course that is what creates the horizon, yeah, and you zoom in on it, and you might see a little gap here and stuff that's not quite at high level. Well, that's all the distortion and what have you, yeah. So our eye level is our height, no problem. Our eye level view is a horizontal view, and when we're talking about the horizon dropping from eye level, you know very well that we are talking about the horizon dropping from the center of the field of view, whether it's a camera or an observer. Yeah, okay. And of course, the other thing is though that what you can also do in your mind, okay, is you can, this is how they go around a level curve. Okay, so here's the center of a spherical Earth with a fixed radius, okay, and they could say, well, as long as I'm the same distance from the center and the same distance, again, we could say this is 200 meters now. We'll say I'm 200 meters above the surface. So as long as I carry on being 200 meters above the surface and over here, I'm still 200 meters above the surface. You can say I've been traveling level because I've the same eye level, the same height, or the same radius. Someone's decided to do some DIY over here as it is over here. That's how they'll end up referring to level. Okay, but that's their level curve. Okay, this is. I don't know if that's disturbing you or not. I think that's. Not sure what someone's doing there. chainsawing or smoking something out. I'm not. Oh, I don't know. Anyway, yeah, that's it. That's just a concept. It's just a definition. In the real world, even though I'm drawing, I think this is. You understand that this is what we mean. Yeah. So let's lesson over. Let's just bring the camera back a second. All right. Hey, and have a look. Right, Milky Henry, that's right. Yeah. Oh, nice set square, thank you. Okay, let's just go back in the chat. Okay. All right. Not too much chatting going on. Okay. A tall observer about good for you. His level. Yeah. Okay. Oh, who we got there? Kevin. Hello. Kevin Balfour. Hello. And it's 7:26 p.m. with you in the real world. Ross. Just ask. Hello. All right. John Tor. Okay. Yeah, you don't have to look down at the horizon of it. And it's the thing, isn't it? It's really about let's just put this over here a second. Oh. Just bear with me. Move this a sec. All right. Oh, that's not too off-putting. Yeah. But it's putting me off. That's for sure. Yeah. Okay. So this is the thing, guys. If you globers defending the globe would be able to come along like that and and just be honest about what we're talking about, establish these first principles. But for 7 years now, we've seen the same thing, and this is why we know that you are defending a belief. Because if you weren't defending a belief, we could very, very easily talk and discuss what we should be seeing, how to set up experiments and observations that would confirm or deny whatever the things that we are said are supposed to happen. And this is the only difference between people like myself and you guys, yeah, that are defending your belief in the globe with these kind of arguments that are obviously meant to be deceptive. And unfortunately, you've got people that jump on them because it confirms their belief. All these things that that flat earthers are accused of are what all these globe defending people come and do. Yeah, use straw man arguments and just change. Just don't do science. We're trying to do science. Yeah, okay. And the whole eye level thing shouldn't be an issue. Horizons happen in the eyes. That's it. Yeah. And the problem is this adherence to the horizon being eye level. Yeah. Or the eye level drop. Yeah. I was trying to explain to someone I know the other day about the whole kind of rocket thing. They were very excited about the mission to the moon. And so I'm saying, well, you know what would be really great? If you want to convert me back to being a globe believer, let's see as this rocket goes up, this Artemis rocket, as it goes up. It's 2022 now, but the person I was talking with was making excuses about not being able to see stars with camera exposure and things like that. I said, let's see the journey. That would be fantastic. Imagine that. Imagine this journey of this spacecraft, man's greatest achievement, going to the moon. We're doing it again. Yeah. Let's see we got the technology now to see the entire journey, beam those pictures back to us as the rocket is going off to the moon. Yeah. Show us everything, views all around. Let's see the Earth receding. Let's see the stars. Yeah. But you talk to someone who's defending their belief in the globe about that, and they just make excuses. They don't say, "Oh, that would be great. Oh, yeah, that would be fantastic." They just make, they don't have time for that. They're not doing that. That's not the point of what they're doing. And it's like, well, what is the point? why are you going to the moon? You know, it's just like all the other things. You know, why are you pretending there are wars? Or why are you pretending that the common cold is something that's going to kill everyone? Yeah, why are you doing these things? Yeah, why are you not? Giving us the technology to have cars that run on water and extract the hydrogen from water, or create hydrogen from water using frequencies. The technology's there. I'm sure the military know about it. They've got it, and they, you know, people have patented it. Same goes for someone like Elon Musk. Yeah, I mean, you know, all these people just adorizing him, thinking the sun shines out of his arse. He's just a businessman. Yeah. And the business model of the cars, the Tesla cars and all, is just nuts, absolutely nuts. I mean, yes, it's a great business model, but it doesn't do anyone any favors. It's just going to cost you a fortune. You have to have, you know, you have to go and charge your thing, whatever. It's just ridiculous, yeah? But is anyone going to come up with a business model that allows you to take water out of your stream or a lake and use a small amount of power to create a frequency that will give you hydrogen to burn? Is anyone going to give you that technology? No, they're going to suppress it. Yeah. So this is the thing, you know, there is good reason to be skeptical of all these people, of all these government initiatives that are basically taking taxpayers' money and funding ridiculous projects. Yeah. As I was saying the other day, I don't mind too much because other things come out of it, and that's understood. You know, these. Maybe getting everyone together to go to the moon is better than fighting wars, yeah. But the wars go on at the same time. It's never not one or the other, is it? It's all happening. It's just. But yeah, this is the thing. Why am I going on that point? Is because you never ever get this demand for the science, and so far we're talking about eye-level horizons. Well. So again, you know, if for example, one of you pilots is gonna with the heads-up display and things like that, you know what you've got to do? If you want to be truly scientific, you just make sure the center of your field of view of your camera is lined up with the horizon line in your heads-up display, and that you make sure that you can show us that you have a horizontal line of sight, and you will see the external horizon in line with your line on the heads-up display. You know that. If you're a pilot, you know that, yeah? And this is the problem, yeah? It's not a problem. I don't care, you know? The thing is, you guys look ridiculous. The more you lie, the more you call names, the more you say, oh, you don't know how this works, or you don't know how to do that, or you don't know mathematics. Doesn't matter. This isn't about mathematics. This is about understanding how we see the world. And also understanding, you know, the very simple fact that if you're on a curved surface, none of that surface is at your eye level, you donkeys. Yeah, it's that simple. So while you think you're laughing at us for not getting it, or not having the mathematical acumen, which we do, it's not, you know, it's a pain to show. It's not part of the thing. You know, mathematics will work if you can, great. You know, if you can do the tangents and the angles and the radius, I mean, who can't do radiuses of circles? It's not that, you know, it's not that difficult. No, it's not. That's all it is. Yeah. But by sticking to that, by sticking to these drawings and these mathematical models and being unable to even inquire or imagine something other than what you've been taught, literally shows exactly what the problem is. The problem is that you have been programmed to think in only one way. And the thing is, we're born into what? We're born into this life on this planet. We don't know where we are, who we are. It's a weird, wonderful, crazy experience. It's mental, yeah. But then you just stick to certain ways of interpreting things because of a geometric presupposition. No, that's just, you know, that's boring. Yeah, it's childish and it's boring. Yeah, and that's not reality. So okay, do your maths, do your thing, and say, okay, this angle there and that distance, whatever. Fine, Fine. That's the wonderful thing about a circle, isn't it? You can make this any distance you like. And that's what I mean about degrees. When we're talking about this, when we're talking about when we're talking about this, when we're talking about navigation and things like that, yeah? Okay. We got a hemisphere. All the globe is two hemispheres stuck together, yeah? But what I was going to say is angles. Everything gets converted to angles, yeah. And then once you have your angles, you can. It doesn't matter. The scale is whatever. You can draw that. You can have this illustrated, and that's what makes it so wonderful. Is once you've converted everything to angles, then it's cool. Now, again, that is as simple as, if you think about it like this, you've got fractions to decimals, yeah? When you've got this, okay? Can you see that? All right, what do I put there? 1/2 is a fraction, 0.5 is a decimal. They mean the same thing, right? Okay? Or if it's a quarter, it's 0.25, whatever. They mean the same thing. But if you're going to do some calculations, you've got to choose one or the other, haven't you? Yeah, you've got to work in decimals, or you've got to work in fractions. And or if you then say, well, that's 2.5. Okay, you've got to come up with a decimal that combines these. Yeah, okay, but then you carry on with your workings in decimal points, and that's the thing with the globe and distances and degrees, is that. That's all you're doing. That's all you're doing. It's as simple as That's why they say, for example, the Haversine formula. Using the Haversine formula to make flight plans. Yeah. Again, Wolfie, this is the only thing. This is all you ever have in defence. Yeah. You'll say, oh, you can't make a flight plan, and we use the Haversine formula. So what? It's very well understood. Whether I can do it or not, whether anyone can change 2.5 into decimal points, yeah, it's the same thing, because all you're doing is converting coordinates, yeah, into you have to have, because you're working in degrees, you have to convert your coordinates and your distances into degrees. So you have a distance of a set distance, and it's across a level surface, yeah. But you just convert it in, you refer to it, the distance, in nautical miles, and then you've got then you're able to translate, you're able to convert 60 nautical miles into one degree. That's it. So you've done the conversion, and that's all you're doing. So the reason you work in the Haversine formula for working out distances and all the other stuff is because you're already, everything's been done for you already. That was done hundreds of years ago. And they've converted everything into degrees, yeah, distances, nautical miles, declination, ground points, distances to and from them. It's all just, and time, it's all degrees, yeah? That's the thing. So because the model you're working in is all in degrees, then whatever measurements you do, whatever observations you make, have to be converted into degrees. That's it. The same as converting fractions into decimals. It's school stuff. It's school grade stuff. That's all it is. It doesn't matter whether you can or can't do it, or whether you use a calculator to do it, or whether you use a piece of paper. It doesn't matter. The results are the same. All of this is a matter of interpretation. All of it. Yeah. It just comes down to, as I said, the geometry of the Earth is really the sky dome, the sky dome of perspective. Yeah. That's it. It's that simple. And so if you can't even get that concept into your head, and you're arguing the toss about models and the way you interpret things and the way you have to ignore reality, then you just look stupid and idiotic, and it looks pathetic, really, because this should be a subject that we can discuss openly without any, issues. And immediately be able to see, well, that does, or that doesn't line up with reality, rather than having the fact that you have to come up with straw man arguments, the fact that you have to, find deceptive ways of explaining things or illustrating things, and then people latch onto them. It just shows that all you're doing is trying to prove something that was actually a ridiculous argument in the first place. Yeah. Because I would, the thing is, you could accept that. You could accept what I'm talking about here is with horizons, yeah? And it wouldn't make any difference. Because as far as I'm concerned, horizons don't dictate the shape of the Earth. They don't that, because horizons are, whether you talk about size or its level or for a certain distance, doesn't matter. I don't care. The point is, and that's why we then go from observations as, let's go to measurable proof. Let's go to measuring. Let's find a way to measure. And of course, what we get is, if you can't understand that it's the distance from the center of a circle, then, that's my interpretation. Well, okay, go ahead, measure it. Don't just expect us to take that for granted as reality when we already know that it's just a way of interpreting. Well, it doesn't even interpret reality. That's the thing. It's just a model. It doesn't even have any relationship to reality whatsoever. That's the thing. We get that. You don't. You're just showing that you don't get that. And this is why I have to come up with, diagrams that should be, fit for a kindergartner. Yeah? How are we doing there in chat? Okay. All right. Hasn't been much chat there, so okay. Maybe I've just been keeping it all... it'd be nice to see if there's any agreement, disagreement, that kind of thing. I've kind of said what I want to say, really. That's what I want to say. That was the point of this whole thing. It's just to try and, get that point across, finally. Yeah? And also explain that, there's no hard feelings. There's no need for nastiness in all of this. And my whole objective for any of this was to just kind of share this wonderful discovery that we're all having. Yeah? Anyway, the chat seems to have frozen. I'm not sure if that's me or whatever. So I'm going to just leave it there. And, bid you all a good day. And I hope that's made sense or just clarified some issues there. Okay? All right, so have a good weekend, whatever you're doing. Yeah? And we shall catch up soon. Okay?